Hello, today I'm going to go over potential energy diagrams. This is a review for us. Now we've done this before a couple of times, okay? So we're just reviewing something here. It talks about these energy diagrams and talks about how to read them, but these images down here are going to be the biggest help. Because on this paper, we're going to be drawing in this information, and I have it listed here. These are all the things that we're going to add to each one of these diagrams. So I'm going to go down the list and add each one of these things to the first diagram. And then I'll show you the second diagram just so you have that as another example. That's already done here. All right, so the first thing, I want my potential energy. So that's the y-axis. So I'm going to write out potential energy. Next, direction of reaction, which is my x-axis. So my direction of reaction. So that's these two I've done. Now I'm going to write my reactants, which is the stuff that I start with. It's always at the beginning of this diagram. That's our reactants, the chemicals we start with. So I'm going to put that right here, reactants. And after my chemical reaction has taken place, at the end, I will have my products. So again, this is showing a chemical reaction. Reactants is what I start with, products is what I end with. So products, I'm going to put right, I'll just write it right here. Products, it's what I end with. So we did both of those. Now we have the activation energy. Well, this is the amount of energy it takes to go from our starting reactants to the top of this peak. That's the activation energy. If it doesn't get that much energy, the reaction will not take place. Think about it like a roller coaster, right? If you don't get the roller coaster up to the top, it's not going to continue on down. If you only get it close to the top, it's going to come back. So we need the activation energy to make this reaction proceed. So that goes up to the peak here. In this one, I'm going to start at my bottom initial energy, and it goes all the way up to this level here. Okay, that is my activation energy. Okay, did that. Now we want to know whether energy was absorbed or released. Well, it depends on where we start with. If we start on this line and we end higher, that means energy was absorbed. But you'll see on this one, if we start on this line and we end lower, that means this amount of energy was released. So let's take a look at this diagram. Well, we started on this line and we ended below. So I'm going to draw from here to here, right? And if we look back here, it looks like energy was released in this. So running out of room a little bit. Energy released. Okay. And then the last thing is, I want to know, was that endothermic or exothermic? Well, if we release energy, that's exothermic, right? We see that over here. If we absorb energy into the products, then that's endothermic. And you're going to write that above and circle it. So in our case, we released energy. Energy released is exothermic. I'm going to circle that. All right. And that's what you're doing with each one of them. Now, I also have this example so you can look at it. I did it the exact same way. It's labeled in the same method. And in this particular case, it happens to be endothermic. So do the rest of these just like these two examples. All right, and let me know if you have any other questions. Thanks.